All right, so for example number 2 out of our textbook, we're given the equation of x squared plus y squared is equal to 25. And I'll graph that in a second. But just so you guys know, and just so you guys, a little geometry / algebra / pre-calc review, that this is just a circle that has a radius of 5, okay? And the center is at the origin, right? And so what they want to know is what is the slope of the tangent line at the point 3, comma, -4. So way down here we've got this point 3, comma, -4. And they're curious, they want to know what's the slope if I were to write the slope of the tangent line through here. Now, normally we just take the derivative, but this is a mathematical relationship. It's an equation, but it is not a function. This fails the function test all day long. So we still have to find the slope of the tangent line, we still need, though, dy dx, okay? So we still need dy dx. Well, that poses a problem for us, okay? That poses a problem for us because I can't just take the derivative by the normal means that what we've learned so far. So the first thing I want to do is I want to graph this. And let me zoom out my screen because it's kind of large. Oh, zoomed out a little too much. All right. So I'm gonna plug that equation in here and we'll graph it. So we have x, whoops, we got to graph this one a little different. We have x squared plus y squared equals, oops, I didn't put plus, equals 25. All right, and let me adjust this screen just a little bit so we can see everything. So we got a circle at the origin, okay? And my circle at my origin is going to have a radius of 5. And so we're interested in the point 3, comma, -4, which occurs right about here, okay? And so we're going to draw a line through here. And I need to write, in order to do the tangent line, I've got to find dy dx. Does that make sense to you guys? All right. So how do I do that? Well, I'm going to have to do implicit differentiation. In other words, what I've got to do is I've got to come in here, and I've got to take the derivative of this, and I'm going to take it with respect to x. Now, when I do that, what I end up with is I'm going to say d dx of the first term, and then d dx of the second term, and then d dx of the third term, right? Well, what are all those terms? Well, I've got x squared plus y squared equals 25. Oh, not 20, 25. And so, well, this is easy. This first one is going to be 2x. Now, we haven't written it down, but really what am I doing? I'm taking the derivative of x with respect to x. And the reason we don't write it down is what is dx over dx equal? 1. 1. What's 1 times 2x?
2x.
2x. So that's how we've always written it down. Now here we have a little bit of a challenge. To differentiate y squared, it's still 2y, but this is dy dx. Uh-oh, I can't simplify that, so I have to leave it alone. Now, there's no x whatsoever in 25, so when I differentiate that, it's constant, and the derivative of a constant is 0. Well, weren't we looking for dy dx? Yeah, so what I need to do is I just need to algebraically solve for dy dx. That's all I need to do. So what I can do is I could say 2y dy dx is equal to negative 2x, divide both sides by 2y, right? And the two y's cancel, and what I end up with is the solution, or dy dx is equal to negative x over y. So this is called implicit differentiation, and I've differentiated y with respect to x. So to find the slope of the tangent line, what do I need to do to find the slope of the tangent line at the point 3, negative 4? How do I do that?
Plug it in.
I've just simply got to plug it in. So what I'm going to do is I'm going to say that dy dx is equal to negative x over y, and I'm interested in the point 3, negative 4, so I'm going to say negative 3 over negative 4, which is really just 3/4.
Why do you do the negative x? Why is it like a negative?
Well, this was the derivative, which had a negative sign, and I could toss it to the front or I could toss it to the back, but if you look at the original, it was on the top, right? It was negative 2x over 2y.
Yeah.
Well, I don't have the equation on the line. Now, they didn't ask for this in the example problem, but I want to write it down just so you guys can kind of have some closure as to what we're doing. So, to find the what's so funny about the word closure? To find the tangent line, what I need to do is I'm going to say that my slope is equal to 3/4, and I'm interested in the point 3, negative 4. So I would say y equals 3/4 times x minus 3 plus, or actually it's plus negative 4, just minus 4. When I distribute that through the parentheses, I get 3/4 x minus 9 over 4 minus 4 over 4. But what's 4 over 4?
6.
Yeah, so it'd be like negative 16 over 4. So my tangent line is actually 3/4, right? 3/4 x minus, is it 25 over 4?
Yeah.
So that's the tangent line. So now if I come in here and I say y equals 3 divided by 4 times the quantity x minus 25 divided by 4, looky there, what do you see?
Tangent line.
Tangent line that touches my circle, which is not a function, but it's a mathematical equation, at the point 3, negative 4. So we're able to do calculus on a mathematical equation as opposed to a specific function by definition, right? Does anybody have any questions about what we've just done?
No.
No. Perfectly good. We're solid on that.